So here is a question on probability, question number 4 to 5 on continuous probability distribution. In particular, this is about a probability density function. The question reads, a function is defined by f of x is 1 over 18 into 2x plus 3 for the interval 2 to 4 for values of x lying between 2 and 4. The first part of the question says to show that f is a probability density function, and the second part of the question asks to find the mean, the variance, and the standard deviation. Okay, so we're going to start easily with a question asking us to show that f of x is a probability density function. Right? Let's start that. So to show that this is a probability density function, there are a few things we need to know, properties of a probability density function. So for a function f to qualify as a probability density function, it has to satisfy the following conditions. One is that the function, when we sketch it or when we graph it, it has to be above the x-axis for the interval that is given. So between 2 and 4, that function needs to be above the x-axis, which is to say that f of x has to be greater than 0 on the interval a and b, where in our case a is 2 and b is 4. That's the first condition. The second condition is that the function, if we look for the area under the graph of this function within that interval ab, then the area under the graph has to be exactly 1. Okay, so let's start by looking at the graph that is similar to this. Here is a function y is 1 over 18 into 2x plus 3. Now clearly this is not a probability density function, and the reason is that the two conditions given there have not been satisfied. So the first one, it might appear within the locality that the graph is above the x-axis, and so that first condition should be met, except that we know, since the function is not restricted, meaning that it extends to infinity on the negative side and to infinity on the positive side, we know that somewhere beyond the 0 there, the graph is going to cross the x-axis and be on the negative side. And that already causes this to be disqualified. Causes it to be disqualified on the basis of the first condition there. All right? The second condition is also not satisfied, because if we look for the area under the graph, if we've not restricted the domain and we look for the area under the graph, it could be anything from 0 to infinity. And because of that, it fails the second condition. And so, if we are going to check whether this function is a probability density function, the first thing is to try and restrict the domain to lie between 2 and 4. If we do that, if we try to restrict the domain, that means we ignore any value of x below 2 and any value of x above 2. So we can say, we could write this way. So we want anywhere below 2, for values of x below 2, we want the function to be 0. So we get rid of the function there. And for any value of x above 4, we also want the function to be 0. So the function only exists between 2 and 4, like that. So this blue line there will represent our function f of x. So f of x is not the same as y there, because y extends to infinity in both directions, and our f of x is now restricted to exist only between 2 and 4. We could write this mathematically using what we call a piecewise function, like that. So this says that the function f of x has a value of 0 anywhere below 2, and also a value of 0 anywhere above 4, and only exists for the interval 2 to 4, like that. Okay? And so once we have done this, then now to check whether this is a probability density function, all we need to do is to test whether the area under this graph is going to be equal to 1, like that. Okay, so can we test if this area here is going to be equal to 1? That is the shaded area. Of course, we can use the trapezium rule directly. When x is 2, we substitute 2 there, and that is 7 over 18. So the x value there is, the y value there is 7 over 18. We can substitute for 4 as well and get that there. The area for trapezium is a half multiplied by the sum of the parallel sides, and then multiply by the distance between them, the horizontal distance between them, okay, which is 2. So we can do that, but because normally these questions are related to integration, we're going to find that area using a method of integration. Doesn't mean that you cannot use the area of a trapezium rule. So any method that works for you can be used, okay? Also, we can, if you're an IB student and this is and you're taking mathematics at AA, that is analysis and approaches, and this came in paper 1, then you'll want to use the quickest possible method without the help of a calculator, because you don't have a calculator in paper 1. So the use of area of a trapezium there would be most suitable because you can find it very quickly. Alternatively, we can substitute into an integral. The area under the graph is the integral from 2 to 4 in our case of the probability density function, if it is a probability density function. So we are going to substitute this function in there and integrate between 2 and 4 and test if that is going to give us 1. If it is 1, then this is a probability density function for that interval 2 and 4. Okay, so let's try and do that. So I've put our function there just to remind us of what we are doing. We're going to integrate that. We need to show that the area under the graph is 1. If we can show that it is 1, then it is a probability density function. Well, to do that, we just integrate between 2 and 4 of 1 over 18 into 2x plus 3. If we do that, integrating, take the 1 over 18 out of the integral, and the integral of 2x is basically x squared, and the integral of 3 is 3x. When you substitute the intervals there, we get this. This is 28 minus 10 is 18. 18 times 1 over 18 is 1. And so we've confirmed that this is in fact a probability density function. F of x is a probability density function. Okay? That's part A of the question. Part B, I've split it into 3 parts. Part 1, to find the mean. Part 2, we will look for the variance. And part 3, we will look for the standard deviation. So the mean, by definition, if f of x is a probability density function, then the mean of the function is given by this function here. Okay, we can show that this is true. If you remember a bit of your statistics, then what we can, if you can remember in statistics, if you're given data values xi and their respective frequencies, let's take some values 2, 3, 4, like that, and suppose this as a frequency of 1 and this a frequency of 3 and this may be 2, then we can find fi times xi, and that would be 2 here. That's the product of x and f, the value of x and its frequency. This would give me 9, that would give me 8, and then I would add this. This is what, 19. So the sum of f times x, xi, right, and the sum of f is what gives us n, and we know that in this case the mean is calculated as sum of fi times xi divided by n. Okay, this is how we find the mean of the distribution. Okay, now if you look at this bit here is actually what we call relative frequency. Relative frequency is in fact probability. So we could write this mean here as the sum of probability expressed as small letter p times xi, which when you look carefully is in fact the same as this. The probability density function f of x is in fact what this pi is. And so what you're having here is x multiplied by p, right? And then we are adding. So the symbol, the integral here is used when we are adding a continuous function. The symbol sigma is used when we are adding discrete functions. So this is exactly the same as that. So it is possible for us to understand where this formula comes from. So the mean of the distribution is the integral of x multiplied by the probability of x, or in this case the probability density function. Let's do that then. Okay, and so to find the mean, we're going to substitute this function in here and then integrate between 2 and 4. And if we do that, what do we get? Let's see. So in our case, we have the integral of 1 over 18, which is that there, and you notice I've multiplied everything in here by x. That's why now we have 2x squared and 3x instead of what we had there, okay? So when we integrate this, either by substituting, putting this directly into your calculator, or going through normal algebraic processing, we can show that the integral of this is given by that. So the integral of 2x squared is 2x cubed over 3. The integral of 3x is 3x squared over 2. And so we have that substituted our limits. And if we do that, substituting 4, first of all, into the first and the second term inside the bracket, we get 128 over 3 and plus 48 over 2. We will leave them as fraction for now. And subtract, then we subtract we now substitute 2 in the same, and we will subtract from that. So like this. Okay, second bracket, if we substitute 2 into the first term there, we get 16 over 3. And if we substitute it in the second term, we get 12 over 2. And when we simplify this, we will get that the mean of the distribution is 83 on 27, which is about 3 and 2 over 27, okay? You can leave your answer like that. If you have a calculator, you can turn that into decimals. It doesn't really matter, okay? So that is how we determine the mean of the distribution. What about part B? Requires us to find the variance of the distribution. Once again, by definition, the variance of a probability distribution is given by the formula that. Again, we can show where this formula comes from. Also, if you're an IB diploma student, this will usually be in the formula booklet. Okay, so the variance is x squared multiplied by our probability density function. Once we've integrated that, we have to subtract the mean squared. Now, we just calculated the mean in the previous part. So substitute this formula or this function in, and then integrate between 2 and 4, and what do we have? If we do that, this is our integral. If we integrate the first part, that's what we get. This was our mean there, squared. And if we solve this, we get that the variance is 0.328, and that is to 3 significant figures. That's all about the variance. To find the next part, I think, is to find the standard deviation. There we go. So to find the standard deviation, by definition, the standard deviation is simply the square root of the variance, which we just found. So, okay, if we know the standard deviation, so the standard deviation of a distribution, this should not be here. So the standard deviation of a distribution is the square root of the variance. And so if we take our variance that we got earlier and look for the square root, we will get the standard deviation. So for this probability density function, the variance, the standard deviation is 0.573, and this is to 3 significant figures. I hope you've understood this, and that if you have any other question regarding this, you will send those questions to me, and we can go through them once again. Just to ensure that you've understood what's going on, I am including 2 questions at the end of this video. Please try them out. I have solved them, and the answers will be in the playlist on problems, okay? And as you read them, you can always pause the video, read them, and try them out before you check the solutions later, okay? Thank you very much. If you like the video, please consider subscribing and sharing these videos widely so that they might help somebody else who might need them.